F of x equals 27x minus x cubed. Justify your answer. So we'll talk about justifying your answer here in just a second. That's kind of a big deal. But let's look at this really quick right here. I see the words f of x increasing or decreasing. If I were you and I was feeling any form of confusion about that, I would make a little note to myself. And I would say, okay, if I'm trying to decide is f of x increasing, I would want to look for this. Where is f prime positive? And if I'm concerned about f prime being decreasing, I want to decide, okay, where is f prime negative? So make a little note to yourself. And I'll tell you what, later on when we talk about f double prime, when we talk about the first derivative test, I got ways to help you organize your thinking, but it can get really confusing because you got f and f prime and f double prime, and they all say different things about each other. It can be kind of confusing. And so I think that it would be a good idea for you to make little notes to yourself to give you a good direction on where to go. Does that make sense from a strategy standpoint? Okay. So let me ask you a question. If we are trying to figure out where f prime is either positive or negative and interpret what all that means, what might I do first with this question?
Find the derivative.
Find f prime, right? Because all I have right there is f. I need to find f prime in order to make these judgments. So let's do that. Find f prime. Good review. Not the most difficult derivative in the world, but good review for sure. So f prime is equal to, any takers?
27 minus 3x squared.
27 minus 3x squared. So use the power rule a couple times and you're good. Any questions there? Negative 3x squared plus 27? Also good. Okay, so I'm going to ask you a question. This is going to be very fundamental as well. This concept will be used over and over and over again. So here we go. If I'm trying to find out where f prime is positive and where f prime is negative, what might be a useful thing to help me decide how to split up the positives and the negatives?
Can you set it equal to 0?
Set what equal to 0?
Set the f prime equal to 0.
That's exactly right.
Look for critical numbers.
Yep, if you want to decide, hey, where is f prime positive or negative, setting f prime equal to 0 would give you an idea about what to do. So I'm just going to tack it on and I'm just going to say equals 0. And you guys know from an assessment standpoint, quizzing and testing, you guys know that writing this thing is quite important, right? So please don't not write that and then just magically solve an equation that you never actually set up. Make sense? So please write that equals 0. It's almost always worth a point or part of a point. It's an important thing to write down. Okay, any suggestions on how we solve this? What do you think, Drew?
Add the 3x squared over to the other side.
Okay, so 27 equals 3x squared. Divide by 3, right?
And then take the square root.
So I'm seeing plus or minus 3.
Yeah.
You guys get the same thing? Yeah. So notice how I'm not hyper concerned about all of your little algebra minutia, right? Adding to both sides, dividing both sides. I want to see that you set f prime equal to 0 and that you solved it. And if you've got a calculator, you could solve something like that, or even more complicated, by just doing the zero finder, right? That's allowed if you've got the calculator. If you want to show all the algebra steps, of course, that's allowed too. Just got to do what you got to do in order to make it work. Okay, so I found out where f prime is 0. I have a little tool that I want to show you guys that I think is a worthwhile tool. We'll use it a couple of times here in this part of the chapter. I'm going to make what's called a sign chart. Okay, so here's what it looks like. I'm going to draw just a number line. I'm going to label it with what it is. So I'm going to do a number line with an f prime on it. And I'm going to put what amounts to my 2 critical points, my 2 critical numbers, on that. Bless you. So I'm going to put a negative 3 here and a 3 here. So I'm making a little sign chart. And I'm going to fill in the signs, like the positivities or the negativities of the different intervals. Do you guys see how I've created some intervals? How many intervals have I created? 3 separate intervals, right? There's one of them right here, another one right here, a third one right there. So there's 3 intervals. All I have to do now is figure out, well, is f prime positive or negative on those intervals? So how do you suppose? What could I do to test to see the positivity or negativity of those intervals? What do you think, Blake?
Test point.
Some kind of a test value. Yep. So what would you guys suggest as a test value? 0 is always an excellent choice. So I will do that. F prime of 0. You can do this in your head, right? Equals? 27, right? It's 27 minus 0. Oh, hey, we laugh because, he was really bold and confident with that answer. But hey, listen, what he brings up is really important because whatever we plug back into matters, doesn't it? Because if you plug a 0 into f, you get one thing. If you plug 0 into f prime, you get something else. So you want to understand, why am I plugging into f prime? Why am I plugging into f? Do you know? Why are we plugging numbers into f prime?
First derivative test.
We're not really doing a first derivative test, say again?
To see where the slope is positive and negative?
Yeah, and slope is represented by f prime, not f. That's exactly right. Okay, so I got a beautiful positive number right there. The interval from -3 to 3, I got a positive. Now there's a number of ways to get the other intervals. You could go with the long and painful route of plugging in two more numbers, maybe like say a -4 and a 4. That would work. It's long and painful. If you remember multiplicity, do you remember multiplicity? If you remember multiplicity, you can immediately just do this. Negative, negative. Remember why? Multiplicity. So this, x equals plus or minus 3. If I went back here and did some of the details, if I, for instance, if I didn't bring that 3x, well, maybe I did this. Couldn't I get this from this equation, 0 equals x squared minus 9? And then doesn't x squared minus 9 factor?
X plus 3x.
Yeah, so if I get this, 0 equals x plus 3, x minus 3. Do you see how the multiplicity on both the x plus 3 and x minus 3 is 1? Like it's x plus 3 to the first and x minus 3 to the first. So if the multiplicity is an odd number, then whatever it is you're dealing with goes through the x-axis. Do you guys ever do multiplicity in pre-calc? I'm just showing you, hey, what I'm trying to do here is trying to show you a shortcut. This by no means is necessary. Couldn't you plug in a -4 and a 4? Yeah. So for those that are kind of tracking with me, if the multiplicity is odd, then whatever it is, it will change signs, right? But if the multiplicity is even, like a 2 or a 4 or a 6 or an 8, then it'll bounce, right? It won't actually go through. Say again?
We kind of talk about conics here.
Yeah, conics have multiplicity issues, right? Because most of the conics are like, x minus 2 squared, right? So they usually have even multiplicity. But those are just, that's just the standard equation, not necessarily the zeros, but it could come up. Definitely. Definitely comes up with parabolas, for sure. Yeah. So your choice on how you want to do this. If you want to plug in test values into all the intervals, that's fine. If you want to use multiplicity, that's fine. The way that most of you are looking at me, listen, the way that most of you are looking at me when I use the word multiplicity, you should just plug in test values. So let me show you that. If I did f prime of 4, what's f prime of 4?
-21.
Let's see, it'd be 27 minus 48, right? So -21. So do you see how that negative agrees with this negative? And then you could also do f prime of -4. That would give you, I think, again, -21. And so hopefully you can see how that negative agrees with that negative. So you can always just do test values. That totally works. Or you can use multiplicity if you want a quicker way. If you don't understand multiplicity, for goodness sake, don't do it. Don't do it. Just because it sounds neat or something, don't do it just because it sounds cool. Do the thing that you know how to do. So the final thing we need to do here is draw a conclusion and justify your answer. So I want to give you an example of this. I want to model this, but you need to figure out how this works for you. I'll do the first one. I'm going to say this. F is increasing on the interval. Let me make my writing a little neater here. On the interval, -3 to 3, because f prime is positive on -3 to 3. So f is increasing because f prime is positive. That's a little saying that I had you try to finish with me earlier. Can I give you guys just a few minutes here and let's see if you can use your own words or start to form your own way of working on justifying and summarizing and concluding, except let's deal with the other intervals. Okay, I've only dealt with the middle one. Can you guys deal with the other two? Okay? Give it a shot. Share what they got. Drew? Okay, let's hear what you did.
F is decreasing on the interval.
Talk slow. F is decreasing on
The interval negative infinity to -3, and the interval 3 to positive infinity because this f prime is negative.
F prime is negative. I usually throw in the on those intervals. Something like that. My L, there we go, on those intervals. Yeah, Drew, I mean, that's obviously quite similar to what I did up there. It's accurate, it's good. You've drawn a correct conclusion. And he did both intervals within the same statement, which is always okay as long as they both share that same characteristic. You guys, did anybody write something slightly different that you'd like to just say out loud and we can check and decide whether that was a good one or a bad one? Did you all do something similar to Drew? Okay. So these things will kind of morph into their own, and it's okay for there to be some level of variety as long as what you're saying is true and actually addresses the question. So, good. Are we ready to move forward? You see how those sayings that I told you guys you had to have them cold at the start? Do you see why that would be a useful thing? Right? If you're trying to determine whether something is increasing or decreasing, then knowing those things would be a good, helpful thing for sure. Okay, so I would say example number 1. If I was going to describe it, I would say example number 1 was very algebra and arithmetic heavy. Okay? I would say that it's going to be relatively rare, not non-existent, but relatively rare that you'll see things like that. I would say example number 2 would be a far more common way to ask a similar question. So, you're really armed with all you need to be able to handle number 2. I'll read it out loud, but let's see if you guys can do this. I'll just let you try this on your own first. So, it says use the graph of G prime to determine the intervals on which G is decreasing. And then notice the graph that I supplied you with down there is not a graph of G, it is a graph of G prime. Okay? So I trust you. I think you can probably do this or at least come close. And so let's see how you do. Give it a try. Maybe figuring a few things out. We're looking for where G is decreasing. Would anyone like to share their answer? John.
Would you consider that 5 or going to infinity?
Let's just say 5 because we don't really know what happens out there.
So it says G is decreasing on the interval -2 and 2 and...
Hang on one second. G is decreasing on the interval from -2 to 2, you said?
Yep.
And then you said and?
And 4 to 5, because G prime is negative during the intervals -2 to 2 and 4 to 5.
So I'll just say on those intervals. But John, what you said is great. I think maybe that's a little quicker. Who knows? So he said, I'll just read it out loud here. You can compare it to what you have. G is decreasing on the interval -2 to 2 and 4 to 5 because G prime is negative on those intervals. So we haven't made a decision whether John is correct or incorrect or close or whatever. So let's make a decision on that first. What do you guys think? Do you think John is correct or not quite? What do you think, Dylan?
I have a question.
Oh, yeah.
First of all, but also, would it be frowned upon to write out G prime as negative rather than doing the less than 0?
Oh,
Is there a
that's-
certain notation, or is it just your preference?
Yeah, to me, this just feels quicker.
Okay.
But
Yeah.
if you say is neg or something, like any G, then I don't know that it's any quicker. That's fine,
Okay.
definitely.
I don't know. I just feel like
So-
it's sometime doing dumb mistakes.
What's the alligator eating?
Exactly.
Yeah, I get it. So you said you do agree with him, or you don't agree with him? I didn't quite catch
I
that.
do.
You do agree with him, okay. Any other opinions on this? Do you all have the exact same thing as John?
I do.
Now's the time to be, hey, every now and then somebody will do a little quick poll like we're doing right now, and almost the whole class except for one person says it's this way, and then the one person says it's the other way, and the one person that said it was the other way ends up being right. It's happened before. So I'm not saying that. I'm not saying either way. All I'm saying is that if you disagree, don't sit there and be like, I don't feel like saying what I said because it must be wrong because John and the other said it. What? Anybody? Yeah. Feel free to non-conform on this, on all of this stuff, right? It's okay. So everybody, I just want to be clear. Everyone's in total agreement? I'm glad you are because he's right. He's definitely correct. Can I ask you a question? I hope this is an appropriate question. Let's see if you can figure this out. What do you think, because I've asked questions like this over the years on notes and quizzes and tests and all kinds of things I'm sure you can imagine. What do you think would be a common and somewhat understandable wrong answer? What do you think, Dixon?
That the slope of the line of G prime is equal to the slope of G.
So what numbers would they maybe use if they were using that thinking?
So if it was decreasing, it would be -3 to -1, and I think
Yeah.
-3, -1, and 3 to 5.
Yes.
So they go like that instead of saying the slope is if it's under the x-axis or above.
Yeah, that is well said, well said. when somebody looks at that, when they're looking at the slope of that graph, what are they really considering?
Acceleration.
Say it again, Tiffany? F prime prime. Sort of an acceleration idea, right? Because isn't acceleration like the second derivative of position? And so they'd actually be looking at G double prime if they considered that. Dixon, you identified it. That is a somewhat common, and you got to say, it's somewhat understandable wrong answer, isn't it? You can see why maybe somebody would say that. But if you guys were saying exactly what John said, you are right on the money. It's time to move on. We good? We good? All right, for the next one, please break out the calculators. We will use those. Question? Hey guys, I don't know. I think this would be a comfort to you. Well, we'll talk about this. We'll talk about that in a second. For now, let's just read it. Let's try to understand what's going on. If you mow your grass at your house, you could identify with this a little bit. It says grass clippings are placed in a bin where they decompose and frankly start to stink. For 0 to 30 interval, the amount of grass clippings remaining in the bin is modeled by A of t equals 6.687 times 0.931 to the t, where A of t is measured in pounds and t is measured in days. So I just want to be really clear about this. We're basically talking about a trash can full of grass, right? And over time, it doesn't really, it does say t is measured in days. So basically over the course of a month, right, 0 to 30 days, the grass clippings just sit there in the trash can and they decompose. And so decomposing usually means that they lose their mass, right? It's being changed into a different form like smell and whatever. And so we've got this A of t. Can you guys tell me this right now? Is A of t, this question might seem silly, but I think that it's worth asking. You'll see why in a second. Is A of t an amount or a rate?
Rate.
It's an amount. Pound.
It does say this, right? It does say the amount of grass clippings is modeled by, where A of t is measured in pounds, t is measured in days. So what would you say the units on A of t would be? Pounds, right? So our ability to discern between an amount and a rate is really important. So A of t is an amount. So the only question associated with this is right here, the little bullet point. It says, find the value of A prime of 15. So that's kind of its own little question, isn't it? This is where your calculators come into play. This would definitely be a calculator active question. So what feature on your calculator will help you do this very quickly? Math 8. So please use Math 8 to find A prime of 15. I'll write this up here. A prime of 15 equals, and I'll let you guys supply the number. 4. You got a negative number. Can you give us a specific negative number?
Yeah, negative 0.1636.
1636. You guys agree with Lauren's negative number up there? Okay. So you guys notice Lauren went a little above and beyond and she went to 4 decimal places instead of 3. Is that okay? It's totally fine. You got to have at least 3, right? So having 4 is fine. Okay. So I want to move on to the next question. It says, interpret the meaning of the value that you just found within the context of the question. So let me ask you a kind of a follow-up question to that. Since A prime of 15 is negative, obviously, Annie, can you tell us just a general idea of what that means? If A prime is negative, A prime of 15 is negative, then
A is decreasing.
yeah, A is decreasing when T is 15, right? That makes sense? Okay. So it says, using correct units, interpret the meaning of that value in the context of the question. So we could say something like this. When T equals 15 what's? Days. You want to include units. So that phrase, using correct units, they really mean that. I really mean that too. So when T equals 15 days, the amount of grass clippings, or the amount of grass, is decreasing at a rate, I want to see that word rate in there, of, let's be extremely careful with how we finish this. At T equals 15 days, the amount of grass clippings, you know what? I'll put this now. I'm going to put in pounds. I was going to put that at the end, but I'll put it now. So when T equals 15 days, the amount of grass in pounds is decreasing at a rate of, how would you finish this? So it's either going to be plus or minus 0.164, right? One of them is right, the other one's wrong.
Plus.
Because you
Because if it's decreasing at a negative.
So if you were, so what you want to have here is just the positive version, and here's why. Because if you just said it, if you're decreasing, like I wrote up there, at a negative rate, what are you really doing? You're really increasing. So watch out for double negatives. Watch out for clear communication.
Wait, question.
So let me write this up here the correct way, and then I'll get your question. So at a rate of 0.164 pounds per day. Okay, Blake's question.
So just to avoid any issues with that, can we just write it like, when T is 15 days, the amount of grass in pounds is changing at a rate of negative 0.164 pounds per day?
Yeah, that's a great question. So that's an accurate description. And in the past at the AP test, they have definitely taken that. I find it hard to believe that they wouldn't take that, although one could argue that you're not really addressing it within the context of the question, right? The fact that the rate of change is negative means that the amount is decreasing. And so I would tend to go in this direction. Although I will say, like if you're picturing some quiz with me coming up later on, if you were to write what you said, I'd probably, I'd say, yeah, this is better, but I wouldn't take any points off. Yeah. So I think I've said a little bit, they have a kind of a renewed emphasis on communication. And so that might be one of those things that are like, we took this in the past, but not now. So something to think about. Sir.
Could you hypothetically put, is increasing at a rate of negative 0.164?
Yeah, you hypothetically could, right? Because increasing at a negative rate really means decreasing, but I would suggest that you keep it simple, right? And it's not, that does seem almost like a contradiction a little bit, but, if you think about the double negative, it does make sense, right? I would just encourage you to think of it in like the normal way, if I can use that word. But yeah, if you're looking for ways to get creative, then it would be kind of hard to argue with that. Yeah. Okay. Any questions? No questions. Okay. Let's tackle this last one. We may or may not finish this right now. And try to just understand, like we did with those related questions, let's try to figure out like what in the world is going on here, right? So let's not worry too much about numbers or anything. Let's just try to figure out what is happening here, and we'll try to figure out how to answer the question later. So it says the amount of water in a storage tank in gallons is modeled by a continuous function on the time interval 0 to 7. So I'd just stop right there and say, hey, there's a tank, and there's water in it. That's all that's really saying, right? Concerned about the time interval 0 to 7. Let's keep going. T is measured in hours. In this model, rates. So if I were you, I'd like make a mental note. Now we're talking not about amounts like we did at the start. We're talking about rates. Rates are given as follows. The rate at which water enters the tank is given by F of T. And the rate at which water leaves the tank is given by G of T. And then it asks a question. So can anybody express what's going on here with this water tank? Just use like really plain, unmathy, unnumber language. Like what's actually happening? Go ahead.
Water's coming in and leaving the tank.
Yeah. There's some water flowing in, there's water flowing out. That's it.
So this is like a dam example almost?
Sure. Or how about like a water tank? That like actually gives water to a town. Like they might be pumping water up into the tank, and then somebody turns on the faucet on their their sink or their shower or something. So doesn't water start to flow out of the tank? Right? It could even be like a water treatment plant, where like, dirty water is flowing into the water treatment plant, and they do all their treating of the water, and at the same time, clean water is flowing out of the plant. Could be something like that as well. It could apply to a lot of situations, right? It could even be gasoline. The big underground storage tanks. Maybe a truck is like putting gasoline into those big tanks. At the same time, you're putting gas into your car, causing the gasoline to leave the tank. There's all kinds of scenarios this could be playing into. But bottom line is, Drew said there's a rate of water coming in, there's a rate of water leaving the tank, and that's kind of what's going on, right? Yeah? Okay. So the next thing I want you guys to do, I want you to go through this, and I want you to underline anything you see that is clearly a rate. Okay, so take a minute, let's underline anything that you say, yeah, that's definitely a rate. There's a lot of clues about that, right? Units are really helpful. Sometimes the word rate even appears. So let's identify which things are rates. And we'll go from there, but let's identify rates first. Okay, so how many rates did you guys pick out? How many? Two rates. So maybe you underline something like this. You know, the rate at which water enters the tank is F of T equals that. Do you see how the units agree with the concept of a rate as well? Gallons per hour. If I told you that the rate was in gallons, that makes no sense, does it? What does gallons measure? An amount, but gallons per hour, that's a rate. And maybe you underline also the rate at which water leaves the tank is G of T equals, ooh, it's a piecewise too. Oh boy.
It's a lot of gallons over the third hour now, leaving compared to the first three.
Yep, definitely. Somebody open up some more gates for the water to leave, right? Definitely. Okay, so I call this, let's go back to the start here. There's two rates, and would it be fair to say that the rates are kind of acting against each other? So I call these competing rates questions. Two rates are competing against each other. You could also call this a net rate situation. Net rate. So net means you're taking into account the rate leaving and the rate coming in. Some people will call these rate in, rate out type questions. There's lots of different ways of labeling them and thinking about them. Okay, so the question. Now that we've kind of underlined our rates and identified what's going on, the question says, on the time interval 0 to 7, find the time intervals during which the amount of water in the tank is decreasing. Make sense? Okay, you don't have to do it this way, but I want to introduce you guys to a way to do this. Did you guys notice at the very start, it said something kind of interesting. It says, the amount of water in the storage tank in gallons is modeled by a continuous function. And did you notice it didn't say anything about that function? It just says, hey, there's a function that models the amount of water in the tank. Fair enough? Okay, so what I'm going to do is I'm going to go ahead and give that function a name. And I'm going to name that function A of T. Make sense? So I'm going to say A of T equals the amount of water in gallons. The amount of water in gallons. So when you see this question, I think this is helpful. I don't think that this is what you'll do all the time when you see a question like this, but I think it's helpful for now. So it says, find the time intervals during which the amount of water, couldn't we rethink of that as A of T? So I'll reread it again. Find the time intervals during which A of T is decreasing. So here's where we kind of step back from the water tank and we say, okay, if we want to find out where A of T is decreasing, we want to find out where
A prime of T is less than 0.
A prime is negative, right? If I want to find out where A is decreasing, I want to know when A prime is negative. Do you see how that fits with the other questions we've been doing? Yes?
Yeah.
So if I'm going to find where A prime is negative, might it be beneficial to know what A prime is?
Yeah.
So I'm going to try to figure that out. I'm going to say, all right, fine. I want to know A prime. So I'm going to write A prime of T equals, and ouch, I have nothing to differentiate, do I? What do I have that might be helpful? I have some rates, don't I? And isn't A prime a rate?
Yeah.
A prime, in fact, represents the net rate, right? It's the rate of change of the amount of water. And it would be exactly what you just said, Dixon. It would be F of T minus G of T. Let's take a minute and think about why that would be. This is a really crucial point, really important. First of all, why is it F of T minus G of T instead of G of T minus F of T? Why wouldn't it not be the other way around? Austin?
So if you're trying to find when A prime of T is negative or under 0, if you're doing F of T minus G of T, since F of T is when water's going in,
Yep.
G of T is when water's leaving.
Yep.
If G of T is bigger than F of T, then it's going to be a negative.
Yeah, very true. Yeah, you're totally right. That was extremely well said. I have nothing to say other than awesome. What would be wrong with me switching it around and doing G of T minus F of T?
If G of T is bigger, then it'd be a positive.
It would be the other way around, wouldn't it? Yeah. So maybe another way to think about it would be to say, if F of T is the rate of water entering, wouldn't F of T be making the amount of water go up? Therefore, we want that rate to be positive. But G of t is making the amount of water go down or decrease, so G of t would have to be the negative one. Does that make sense? Okay. One final question. I have A prime, don't I? Why didn't I say A prime of t equals F prime minus G prime?
Because we don't have,
Those are already bounced.
F and G are already rates. Remember how we went to the trouble of underlining the rate, the blah, 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 the rate, blah, 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 right? We went to all that trouble to say, hey, these things are already rates, so let's recognize F of t and G of t, they go with A prime, don't they? F prime and G prime, that would be the rate of change of the rate of change. Almost somebody might even say, is that sort of like an acceleration of the water leaving or entering? Yeah, kind of, I guess, sort of. But we don't want that, right? We just want to know the rate at which the water is entering, the rate at which water is leaving. So, which is an acceleration thing, right? Sort of an acceleration, right? Yeah. Okay, so I did give you the graph. Did you guys notice that? I gave you the graph off to the right. So, that graph, which would you guess is which graph? Which one's f of t? The curvy one is f of t, right? G of t is the piecewise linear. And so, I'm looking at this, and, Austin's idea. Will you say that again, Austin? You said it really well. Like, how could we determine the positivity or negativity of A prime? Well, you said whenever.
When G of t is bigger than F of t.
Yeah. So if I'm trying to figure out where G of t is bigger than F of t, I could say it a slightly different way. I mean, you're saying it wonderfully, and I had got no issues with that at all. But let me show you how this could work. If I'm looking for when the amount of water in the tank is decreasing, wouldn't I be looking for this? Watch carefully. When F of t minus G of t is negative. You follow that? Because if F of t minus G of t is negative, that means that A prime is negative, which means the amount of water is decreasing. But if I just take this and add G of t to both sides, I get F of t is less than G of t. We could look at the graph and see this pretty clearly, right? Where is F of t less than G of t? Let's see here. F of t is the curvy graph, right? So I would say, I'll highlight it here. We can figure out the numbers in a second, but I would say that the curvy graph is less than the line graph here and here. See what I'm saying? So if we could figure out these intersection points, like right here and right here, then wouldn't I have the other ends of the intervals pretty easily? How could we figure out those two blue intersection points? By using the
first derivative test.
think way simpler. How do you find intersection points?
Set it to 0. The A prime of t.
Not,
Set them both equal to.
yes, Dylan, you're correct. Setting A prime equal to 0. But like, what mechanism would we use to find where A prime is 0?
do math 8.
No, because we're not differentiating anything.
Do you have
One's
to?
definitely a 3.
I bet you. Yeah, definitely. There's a 3 in the middle. I agree. So it's going to be, for the one on the right, it's going to be 3 comma something, right? And isn't
Find the slope.
I'm wanting to know how to find these blue points, right? Because if this is the interval I want, and this is the other interval, don't I know it's going to be from 0 to whatever that is? And then from 3 to whatever that is? So how do I find those points? What do you think, Noah?
F of t like equal to 250 to 2000.
Yes, and then what mechanism would I actually use? The calculator. Wouldn't you find the intersection points with your calculator? And you guys might have said that. I was like so many voices going on there. So I'll tell you what. That can be your mini assignment for the afternoon. We're up against our time. Find those intersection points and complete the question. It shouldn't take you too long if you know how to find your intersection points. Okay? We'll maybe double check this one when I see you guys next time. Have a good day. So I used the calculator intersection finder to find these two blue intersection points. And so this point right here, the t value of intersection is 1.617. And over here on this one, the t value of intersection is 5.076. So we could conclude our question by saying A of t is decreasing on the intervals 0 to 1.617 And also 3 to 5.076 because, and then there would be a lot of becauses that would work here. So I'll give you a couple of options. You could say because a prime of t is negative on those intervals. That would be one way of saying it. And let me see if I can spell intervals. There we go. You could also say, as just a conclusion justification here, you could say because f of t minus g of t is negative, again, on those intervals. You could also say it a third way. You could say because f of t is less than g of t on those intervals. So there's really three ways, at least. We maybe could come up with some other ways too, but three ways right there for you to write this. And all of them should work. So I hope that works with you. We'll double check in class when I see you next time to make sure this all worked for you. If you remember how to do your intersection finder, and if we are okay moving forward with this. So have a great day. See you next time in class.